Solving an equation means finding the number value that makes the equation true, makes it a true statement. The solution or solutions that make the equation true make up the solution set. If the solution is 3, we can write the solution as 3 with set notation around it. You'll see that in your homework. So let's just practice solving this equation. This should be review. So I'm going to write it over here so that it's a little bit bigger for me to use. I usually start by drawing a line straight down through the equal sign. That keeps my two sides separate from my eyes. The first thing we need to do is move the plus 5. The opposite of plus 5 is minus 5, so I'll subtract 5 on both sides. That leaves me with 4x on the left, equal on top of my line, and 24 on the right. The 4 in front of the x means multiplication, so the opposite of multiplication is division, so I'll divide both sides by 4, and that leaves me with x equals 6. Or I could write the solution set as 6. The first step for solving a more complex equation is to multiply to move the parentheses. Could then combine like terms. Move your letters to one side and your numbers to the other side by adding or subtracting, and then the last step is to multiply or divide to get the letter by itself. So again, I'm going to write this over here so that it's a little bit bigger. And the first step we need to do is get rid of the parentheses. So I'm going to multiply that 4 by everything that's inside the parentheses. That gives me 8x plus 4. Here's my line. Over here I'm going to just copy the 29 plus. But here this 3 in front of the parentheses needs to be distributed through or multiplied by everything inside. So I get 6x minus 15. Then my next step is to combine any like terms that I can. Well, over here I have a 29 minus a 15, so I can combine those. So I'm just going to copy 8x plus 4 over here. And 29 minus 15, well let's write the 6x first. And then 29 minus 15 is a positive 14. So I'll write plus 14. Now I'm going to move my letters to the left, so I will subtract 6x from both sides. And that cancels this out over here and leaves me with 2x plus 4 equals 14. Then I would subtract 4 from both sides. That cancels the 4 over here. Notice I'm moving the numbers to the opposite side. I move my letters to the left. The x is to the left, which means I need to move anything without an x to the right. So it gives me 10. I'll write that over here just because I'm kind of out of room. My last step will be to divide both sides by the number in front of x to get the x by itself. So x equals 5. Or we could write it in the solution set of 5. Notice when we write it in the set part, we don't write the x, we just write the number. If the equation has fractions, then we need to multiply every term by the common denominator. Or sometimes we just write LCD to get rid of the fractions. So one way to do that, let me write this a little bit bigger, is to look at the numbers in the denominator and break them apart into the smallest possible numbers. So 4 can be broken down into 2 times 2. I'm going to leave a space there because I'm going to come back to it. 14 is 2 times 7. I'm going to leave a space there, and x plus 5. 7 can't be broken down. So if I look at my denominators, this denominator has 2 2's, this one has a 2 and a 7, and this one has a 7. So this first fraction doesn't have a 7 in the denominator, which means it needs 1 because there is 1 here and here. So I'm going to multiply the top and the bottom by 7. Now this next fraction right here has a 2 and a 7, but it doesn't have a second 2 that this fraction over here has. So I'm going to multiply the top and the bottom by a second 2. And then finally, this third fraction has a 7, but it doesn't have these two 2's. So I need to multiply it by two 2's on the top and the bottom. So we're multiplying by what it's missing in order to make the denominators all be exactly the same. So every denominator now is a 2 and a 2 and a 7. So let's do some simplifying. Over here, I'm going to distribute that 7. That gives me 7x minus 21. On the bottom, 2 times 2 times 7 is 4 times 7, which is 28. Then in my next here, I'm going to take 5 times 2 is 10. In the bottom, I get 28 again. Minus, and then here this is 4, and that 4 needs to get distributed, so I get 4x plus 20 over 28 again. Now once the denominators match, we can just cross through them. We don't have to worry about them. So we really have 7x minus 21 equals 10 minus, and now here's where we have to be careful, because all of this was on the top and there's a minus in front of it. We need to keep it in parentheses or else we'll get the wrong answer. Probably we just need to think about it as having that here too. So now we've got a new problem that we can work without any fractions in it. And if you'll give me a minute, I'm going to rewrite it, clean up my screen a little bit so I have room to keep going. Okay, now we've got some more room. So the first thing we need to do is get rid of these parentheses. So this negative in front needs to be distributed, and when we do that, it changes all the signs. So I'm going to copy this over here and copy the 10, and I get minus 4x minus 20. So again, the next thing we'll do is combine like terms. So there's nothing to combine on the left. I'll just copy that. I'm going to copy the negative 4x first, and then 10 minus 20 is a negative 10. So I'm going to move my letters to the left. So I'm going to start by this minus 4x, and I'll add 4x to both sides. That cancels this out. It gives me 11x minus 21 equals a negative 10. And then I'll add 21 to both sides. And that cancels that out. So I'm left with, I'm going to write it over here, 11x equals 11. And the last step is always to divide by the number that's in front of the x to get x by itself. So 1 is my answer. So here's another problem that works the same, has the same idea. I'm going to rewrite it, but as I rewrite it, I'm going to break apart that denominator. So let's think about 18 for a second. That's 2 times 9, or that 9 can be broken down further as 2 times 3 times 3. Okay, so now I'm ready to start looking at what we're missing. This problem, the first fraction has a 2 and an x, but it doesn't have these two 3's. So I'm going to put 2 3's on the top and 2 3's on the bottom. Now this next fraction has a 2 and 2 3's, but it doesn't have the x that's here and here. So I'm going to multiply the top by an x and the bottom by an x. And then this last fraction has 1 3, but it doesn't have a 2 and it doesn't have a second 3. So we need to have a 2 and a 3 and a 2 and a 3. So now let's do some simplifying. Here we have 3 times 3, which is 9, times 5, which is 45. On the bottom we have 3 times 3, which is 9, times 2, which is 18x equals. Here on the top we get 17x. And then 2 times 3 is 6, times 3 is 18, so 18x again on the bottom. And here I have 1 times 2 times 3, which is 6. And 3 times 2 times 3, which is 18x again. Now once the denominators match, we can cross through them. And so our problem is really just, oh, I forgot to write the x there, 17x minus 6. I'll draw my line down. There's no other x's to combine, so I'll just start by moving that plus 6 to both sides. And that gives me 51 over here equals 17x. And then I can divide both sides by 17. And then x equals 3. We'll do 2 more of these. So I'll start by writing this a little bigger. So here when there's subtraction on the bottom, that's all one piece. X minus 2 is glued together. We can't break that apart. So I'm going to put it in parentheses so we can see it more easily. So when we look at this fraction has a 3 in the bottom, but this one doesn't, and this one doesn't. So we need to take this fraction and multiply by 3 over 3, and the same with this one. Now this last fraction has the 3, but it doesn't have the x minus 2. So it needs an x minus 2 and an x minus 2. So when we rewrite this, we'll multiply this top, so I get 3x. But on the bottom, I'm just going to leave it as 3 times x minus 2. And here I have 3 times 2 is 6. And the reason I'm leaving it on the bottom is because I'm going to cross through those denominators in a minute when they all match. So here we can take this 2 and distribute it. Keep that minus there. So I get 2x minus 4. And now, like we just said, those denominators all match, so I'm going to cross through them. There's this minus sign here, which means this has to be put in parentheses after it. So I get 3x equals 6 minus 2x minus 4. I'll distribute that minus. So I get 3x equals 6 minus 2x plus 4, because remember that minus changes the sign of both of those pieces. And I'll combine these. So I get 3x equals 10 minus 2x. My x's need to be on the same side, so I'm going to add 2x to both sides. That cancels it out over here and leaves me with 5x equals 10. And the last step is to divide that by 5, so I get x equals 2. Now, I just circled that answer, but look what happens when I try to put that 2 back up in here. The bottom was x minus 2, right? So if I put 2 in for x's, just this first fraction, I end up with 2 over 0. And we can't have 0 in the denominator. That's a big problem. So that means we can't have an answer of x equals 2. So because the answer that we got doesn't work, because it gives us 0 in the bottom, we have to write no solution. And you do have to be careful about that when you're doing fraction problems. So we'll do one more problem. This problem says make y1 equal y2. So if we do that, here's y1. We'll write 1 over x plus 4, and I'm going to put that in parentheses because that needs to be glued together, plus 1 over x minus 4. Again, I'm going to put that denominator in parentheses. And we want that to equal 22 over x squared minus 16. You can put that in parentheses if we want. But this should look familiar because that can be factored. So let's rewrite that. So this is a difference of squares, and it can be factored as x plus 4, x minus 4. We do expect you to remember how to factor from foundations of math or foundations of algebra or Dev Math 3 or whatever high school algebra classes you've had. If you don't remember how to do that, we need to talk, or I can refer you to some videos that might help you remember how to do that. But you can see that this fraction has both an x plus 4 and an x minus 4. This one has an x plus 4, but it doesn't have an x minus 4, so we're going to put that on the top and the bottom. This one has an x minus 4, but it doesn't have an x plus 4, so we're going to write it on the top and the bottom. And sometimes I write it in front of the fraction that was there, and sometimes I write it after the fraction that was there. It doesn't really matter because we just have to put it both on the top and the bottom. And now that's going to make our denominators all match. So I'm going to cross through all of these denominators, and I'm going to rewrite what I have. This is 1 times that, so that's just x minus 4 plus, and this is 1 times that, which is just x plus 4 equals 22. So I'll combine like terms. This x and this x together give me 2x. And this minus 4 and this plus 4 cancel out. So I get 2x equals 22. So let me write that over here. 2x equals 22. The last step is to divide by whatever number's in front of the x, which gives me x equals 11. If we go back and we check our denominators, 11 plus 4 in the first fraction doesn't equal 0. 11 minus 4 in the second fraction doesn't equal 0. And in the third fraction, 11 squared minus 16 doesn't equal 0. So we're okay with this as an answer, and we can write it either way. There's 3 types of equations. We're going to use this later on too, but the first type of equation is true no matter what x is. This would be an example like 5 equals 5 or 2x equals 2x. You kind of end up with the same thing on both sides. Those are called identities. The second type of equation is true only for certain values of x. This is when we solve like in these problems, like x equals 4, x equals 0. It's when you find an actual answer for x. And those are called conditional equations. And the last type of equation are equations where there is never an x that works. It's not true. So it'd be something like getting 0 equals 2 or 4 equals 5. So these are called inconsistent. It means there's no solution. And that's our first section.